The previous examples that we saw could be summarized with these rules. These rules are not in your formula booklet and they're not worth memorizing. Instead, let's think about integration by substitution. So what we're looking at specifically is that if we see a composite function multiplied by the derivative of the inner function. And this may not be the full derivative directly. So for example, if I had the integral of x squared, let's say x squared plus 5 to the 7th power times x dx. So the derivative of the inside is 2x, or 2x dx. And I don't see that exactly out here. I just see the x dx. Remember, I can always rearrange coefficients and constants. But if I see a product and a portion of the product is similar to the derivative of the inside, then I'm thinking substitution. So let's look at what I would think of as the term to be substituted. So these are some examples that we saw earlier. In fact, are these all the examples we saw earlier? We didn't see this one. So these are the examples we saw earlier. I'm not going to talk about those. Let's go to the more complicated ones. All right, so here I see sort of an inside, and this looks like the derivative. So I'm going to let the inside be my u. And then I'm going to take the derivative. So this is du dx, yeah? But I'm going to multiply that dx to the other side. Now I can see x dx. So 1/2 du is x dx. So when I substitute, I've got my x dx, which I see here, and I've got my x squared plus 2, which I see here. So I could say that this integral is the same as the integral of 1/2 u du. I can easily integrate this. That's going to be 1/4 u squared plus c, 1/4 x squared plus 2 plus c. X squared plus 2 quantity squared. Remember, I can always check by taking the derivative. So 2 times 1/4 is 1/2. So if I check, I have 2 times 1/4 times x squared plus 2 to the 1st times 2x. So 2, 2, and 1/4 cancel, and I get x times x squared plus 2. This one I wouldn't actually do with substitution though in general. This one I would just expand because that was super easy to expand. So let's look at this one. I see two complicated things I can't simplify, and I see x cubed plus 2x squared. Here I see 6x squared plus 8x. So I went down a power, down a power. So I'm going to try letting my u be the x cubed plus 2x squared. Du dx is 3x squared plus 4x dx. Well, that's really similar to this. 2 du is 6x squared plus 8x dx. So now I can replace this whole, my numerator and the dx, I can replace with 2 du. My inner part of the square root, I can replace with my u. So let me make that one my u. So I'm going to end up with integral of, so that's going to be 2 du. So I could put the 2 in front, 1 over root u du. This I know how to integrate. That's the same, of course, as 2 integral u to the negative half du. I'm going to add 1, so I'll get a half. So I will take my 2 and divide it by a half. So I'm going to get 4 u to the half. That's going to be the square root of u. Of course, the square root of u is square root of x cubed plus 2x squared. No dx. I've taken the integral, but I need to add my constant. Here, I want to think about the fact that the derivative of ln of x is 1 over x. So if u is ln x, then du is 1 over x dx. So I can substitute here. I get the integral of u du. Integral of u is a half u squared, but my u was ln x plus c.